Very good. I appreciate it. How are you? How's everybody? All right. Good stuff. Good stuff. Come on in. Have a seat. We have very little time. We have, what do we have, about an hour? 50 minutes, something like that? So let's say it's 15 after. What does that mean? 5 after I finish, roughly? At 5 o'clock? Let's just say 5:05. It'll be fine. It'll be fine. Okay, good stuff. So, good stuff. Welcome, everybody. Come in. We don't have a lot of time. We have almost no time at all. So, as a result, a couple things. First and foremost, this is the best slide that you're going to see in this hour here in this room. This slide has everything that you need to be able to follow along at your own leisure later on. If you have questions, if you have comments, whatever, don't hesitate to reach out to me. I'm happy to help. I'm happy to answer questions. I'm on the internet. Can you please turn those lights off? Yeah. Yeah. Oh. I'm happy to answer questions. I'm happy to answer questions. How many of you are on the internet? How many of you are on Twitter? I'm just curious. 2019, almost 2020. Twitter. Anybody? Who's using Twitter? Twitter. All right, the rest of you, what are you doing? Get on Twitter. It's a great place to be. It's the new IRC. It's where the developers that drive the open source that power your business are. So you owe it to yourself to be there. Go to Twitter. What about email? Email. How many of you are using email? Is anybody using email? No. Good. Moving on. I'm not really a big fan of email, but I've got a little bit of a soft spot now. I've grown to like it slowly over time. This is a brand new Mac. Oh yeah. All right. All right. Good stuff. It's a new MacBook Pro. This MacBook Pro I bought last year with 32 gigs of RAM. And my expectation was that when I bought this, that I would be able to run both Slack and Chrome at the same time. Still not there. Still not there. So I'm very happy with email now, right? Because I prefer it to Slack. So good stuff. Okay, so we've got that. There's also the code. So if you have questions, comments, whatever, if you want to follow along it later on, you can see the code there. You can study it at your own time. All right, my friends? Good stuff. So while you're all here and while you're all getting sat down, come on in. We're going to take care of some very important responsibilities, some very important duties. You see, I have a child. I have a daughter. She's a teenager. She's very smart, much smarter than I am. And, I like to go to these conferences, and I like to take selfies when I go to these conferences. Is that okay? Can we take a selfie? Okay, good stuff. I like to take selfies, and what I do is I take the photos, and then I go home, and I show my daughter. I say, see, they listen to me. So that's what we're going to do, okay, friends? Just pretend like you're happy. Oh, look at that great Devoxx logo right there. Devoxx. Devoxx Ukraine. Say what? Woo! Good stuff. Thank you, everybody. Now, let's get to it. So, a little bit about me. My name is Josh Long. I work on the Spring team. I'm a developer advocate for the Spring team. I've been there for almost 10 years. They made a toy out of me in China. I thought that was kind of cool. I have videos on Safari. I have a book called Cloud Native Java. How many of you have heard of this book, Cloud Native Java? It's a book that I wrote that's all about how to build applications that survive and thrive in the cloud. The book is all about how to take advantage of Spring Boot, of Spring Cloud, and technologies like Cloud Foundry to build cloud-native applications. And the book was something that I was hoping to be done with very quickly. My co-author and I, we spent a little bit of time writing the book, and we thought we would be done very quickly. And it took a little longer than we had expected it was going to take. We didn't know what it was going to take, how long it was going to take. We thought maybe 6 months, maybe a year, we would be done very quickly. But it took just a little bit more time than 6 months. Not much more, okay? A little bit. Just a tiny little bit. Not even it was not a big deal, all right? It was just a small delay involved in getting this book out the door. And there's a lot of reasons for a delay like this. I don't know I can't point to one thing. There's a lot of delays, okay? It was a small delay. It was a very small delay. Not even it was nothing. It was nothing. It was like 2 years, okay? It was like 2 years extra that it took to get this book done. But I'll explain why. We spent the first 6 months finishing the book Okay, no problem. And we spent the extra year and a half deciding the animal for the cover. Now, anybody who knows anything about O'Reilly books knows that it doesn't matter what's in the book itself. Nobody cares. It's what's the animal on the cover. And we knew that if this book was going to be successful, we had to do a very good job. So we eventually chose a bird that is only found in the Indonesian Java Islands. It's a bird called a blue-eared kingfisher. And it's only found in the Indonesian Java Islands. In English, you would say that the bird is native to the Indonesian Java Islands. So it's a bird that is only found in the Java Islands. It's native to the Java Islands, and it's a bird, and birds fly, yes, through the clouds, So it's a bird that is native to Java that flies through the clouds. It's a cloud-native Java bird. It's a bird that flies. Never mind, it'll come. Give it time. So there's that. I have a podcast every Friday. I have a blog every Tuesday, a screencast every Wednesday, and I'm working on a new book called Reactive Spring, which you can buy now, but it's not done. This is all very well and good. It's lots of different stuff. Today we're going to talk about testing. You can see that by the sum of my work, by the things that I talk about, the things that I care about, you can see that I care about building software, and hopefully you can see that I care about going to production. And that's ultimately what everything I think about focuses on, is how to build software and move that software quickly and capably into production. And so software today, it's more and more complex. And so we need to be able to assure the quality of that software. So today, my friends, we're going to talk about testing. We're going to talk about testing with our Spring application. We're going to take a simple application and scale up the application and introduce different moving parts. As we do this, we're going to focus on test-driven development. The goal today will be to write code first for the test code, and then to deliver the production code. The goal here is to see what we're doing as we do it, to have an idea of what we want to do, and then to deliver production code that matches that goal, right? Normally, if you had the possibility, you would do this with somebody else. You would pair program, right? This is a very common situation. And you might have somebody write the tests for you, the failing red test, and then you write the green production code, right? That's a very natural thing to do. It's called red-green refactoring. I write the failing red test, you write the production code that makes my test work, okay? Test-driven development is a very interesting approach. I don't think it's controversial in 2019 to ask or to assume that you're all doing tests. How many of you are doing tests? 2019. Oh, I don't see every single hand. That makes me want to take a shower. Why isn't everybody writing tests? Okay, but anyway, let's assume most of you are writing tests. But I assume that some of you are not doing test-driven development. And that's what I really want to talk to you about today, is this idea that we're going to write a test first, and we're going to introduce these changes slowly. Writing test first has some benefits that I don't think most people appreciate. First of all, it gives you better code. Because when you write testable code, you must write code that can be extracted out. You must write objects that can be extracted out from another. They can be swapped out as dependencies, right? This creates better, more clean, more object-oriented code. This is a good idea, right? So test-driven development requires you to write testable code, which creates better code, right? More usefully extracted out. Test-driven development also has another side effect, another benefit that I don't think most people appreciate. And this is the thing I like about it. It's fun. That's the thing that I care about here, is fun. I want to be able to have fun in my work. How many of you have ever sat down in the morning at 9 o'clock at night and then worked for an hour or 2 or 5, and then the next thing you know, it's 9 o'clock at night? Anybody ever do that? You just start working, and the next thing you know, it's tonight? Because you're having fun, right? You don't notice the day go away. You don't know that the sun has gone up and down and so on. You're in the zone, right? Do you know that expression, in the zone? We talk about this all the time. But it's not just programmers that talk about being in the zone. Lots of people talk about being in the zone. People that do jogging, they like to go for marathons, these kinds of things. Those people talk about getting into the zone. they start running, and the next thing you know, they're like 10 miles away or 20 miles away. They got into the zone, and time flies so fast, they don't even notice it. Gamers, people who play video games. Do any of you play video games? Video games? Okay. People who get into video games, they talk about getting into the zone. This is a very interesting thing. People who sit down at 9 o'clock at night in the morning, and then they start playing video games, the next thing they know, it's tonight, right? And the reason is the same thing. If you do test-driven development, if you run marathons, or if you play video games, you are given a constant stream of horizons, of goals that you can reach easily. A constant stream of things that you can see and achieve that give your brain that sense of satisfaction that you've done something. Our brain needs that. It's an actual stimulus. Have you ever played a video game that's really, really hard to beat? It's very depressing. People don't like that at all, right? Very, very bad result. But if you have a game that is it's not too easy, but it's hard enough that you feel good that you've accomplished something, that game becomes addictive, right? Game designers know this about human beings. They know that we get addicted to achievement. So test-driven development gives you that same sense of fun. It makes you feel like you've achieved something because you are constantly writing just a little bit of test code and then making the code green. And as soon as it's green, what's happened? What can you say about your system if the code is green? You can say, first of all, that the test code is working, but also you can say that the production code is working. You're done. You can go home, right? This is different from the normal way that we think about it. Normally, you write code, then you write the tests. And it feels like a chore because you've already had that nice moment where you wrote the code and it worked. You're like, oh, that's so awesome, it works. Now I have to write the test, right? It feels like an errand or a bother. Same thing for documentation. Nobody likes to write documentation. It's extra work that we have to do. It's so easy to say, oh, I'll do it next time, right? Or I'll do it later. This is how you get into bad situations. So we're going to do test-driven development because we want to write more elegant, more clean, more object-oriented, more concise code. We're also going to do it because we want to write more testable code and because we want to have fun. So my friends, as usual, we're going to start our adventure today by starting a new application. Now, first of all, the 31st of November, that was 2 days ago. Sorry, 31st of October was 2 days ago. That's Halloween. And Halloween is all about spooky stuff, right? So, in the States at least, I'm not sure about here, but in the States, kids, they go dressed in Halloween costumes, really scary things, Me, I went dressed as an application server. It was terrifying. Terrifying. Just terrifying. So, we have our start.spring.io experience. You can see it's all, off. Oh, thank God. Now, we have our start.spring.io experience. You can see it's been, made up for the holiday, right? So you can see this really nice design. You can see the spider here, right? You can see the ghost down there. Good stuff. Okay, so we're going to build an application today, my friends. Oh, yeah. Oh, wow, there's so many of you. Good stuff. So we're going to build a new application called a producer. And we have some choices that we need to make, some choices that we need to care about here in our application. You are going to choose options, and then, my friends, you are confronted with a few different choices here. The first choice, of course, is what version of the JVM do you want to use in 2019, almost 2020. There are three choices here, my friends. Only two of them are correct. I'll give you a clue about which one is not correct. It's this one. That's the wrong one. Don't use that, okay? So we're given two versions now. We have Java 13 and Java 11. Java 13 is the current long-term version of Java. Java 13 is the current supported version of Java. Java 11 is the current long-term supported version of Java. Both of these are correct. This is not correct. It's ancient, it's old, it's deprecated, it's dead, it's no longer a thing to use, it's expired, it's past its prime, it's stinky. So don't use that. Instead, use the latest and greatest. So you can choose whatever you want. I'm going to use Java 13. Remember, using Java 13 and Java 11 is not just a good technical decision, right? It's a good technology. It's a good technology decision because it gives you latest updates, it gives you faster runtime, gives you faster execution. It's also the morally correct decision. It's morally the correct thing to do. After all, are you prepared to go home and talk to your children and explain that you're still using Java 8? Are you ready for that discussion? I don't think you are. I don't think you've thought this through. No. Use Java 13. Now, my friends, we're going to build a new application. We're going to call it a producer, and we're going to take advantage of certain dependencies here. We're going to build a reactive application. So we're going to use the reactive web support. Okay, here we are. Good. We're going to use Lombok, and we're going to use reactive MongoDB, and we're going to use the Spring Cloud stub verifier. Okay, and with that, I'm going to hit generate, and that's going to give me a zip file that I can open up in my IDE. And it doesn't all that much matter which one do you use. Okay, anything will work just fine. Good stuff. Good stuff. So I'm going to use this. Anything with Java 13 support will work just fine. Public static void main, etc. Okay. Now I'm going to open this up in IntelliJ. How many of you are using IntelliJ? I'm just curious. Good stuff. How many of you are using Eclipse? I love Eclipse as well. How many of you? Wow, that's. Did you see that? There's like 5 people. There's hundreds of people in this room. 5 of you raised your hands for Eclipse. What about NetBeans? NetBeans. Okay, good stuff. Yeah. There's people there too. So lots of good choices there. It doesn't really matter. Now, we're going to build a new application. You can see we've got a public static void main entry point. Can you see that font all the way in the back? I don't know if you can. Let me make it bigger. Okay. Okay, good. So there's our font. There's our application. This is our entry point, but we're not going to start with the entry point. A useful thing to know about in IntelliJ is if you hit Command-Shift-T, it takes you to the test. And you can see I've got this JUnit test, JUnit 5 test that's been brought in for me by default. You see, when you create a new Spring Boot application, since 1.0 or since before 1.0, you are automatically given the test support. Now, this is using JUnit 5 by default. I'm going to use JUnit 4 because I think most people are familiar with that. But either way works. And so I've just excluded JUnit 5. I'm now back to a default JUnit 4 thing. And I have this test that was written for me, and this is a JUnit 5 test. That's okay, though, because I was going to delete this test anyway. It's not actually a very good test. It tests, it's too broad. So what we're going to do is we're going to test 2 different ways, right? We have 2 different options here for how we want to test our application. One is called inside out. So you start from the inside, and then you work your way out. The other way is outside in. Which one you choose is up to you. There's some good choices here. Outside-in testing means that you start with the small components, the entities, the services, the controllers, the REST APIs, etc. That's outside-in. Inside-out. Or outside-in is where you do the APIs, the user interfaces, the controllers, the services, the services down there, and then you go down to the components and the entities and so on. Which style you choose depends, I think, largely on the team that you're working on. If you have 2 different teams in the organization, and they're both working on different APIs, and one project, one API has to interact with the other, and you are worried about the integration, then that integration is something that you should fix and lock down ASAP, up front, right? This means that you should start with the risky outside in. You take away the risk of the integration points for these 2 different services by building the API first, right? That's outside in. On the other hand, the problem with that approach is that it requires both teams to coordinate in the very beginning of the project. And so if you're not sure about the space, if you haven't really sketched out the design, if you're not sure about how each individual thing is going to look, then it might be more viable for both teams to just start working independently and concurrently. In which case, these teams should do inside out. They start with the small stuff, and they keep building until they get to the API. And that's the integration layer, and they can worry about integrating that later. Okay? It's up to you. Again, valid choices, both of them. It's all about how you want to work with other teams. We're going to do inside out. We're going to write code, small code, and then more code on top of that until we get to our APIs. And so for the first thing I'm going to do is going to build a test that tests my Pojo. Okay? I'm going to create a little Pojo called a reservation. All we're going to do is test that I can, create instances of this object like so. So I'm going to create a new object, reservation R, new reservation. And you can see that as I do this, it fails. There's a red line there. The compiler is telling me that type doesn't exist. So I need to create that type. There we go. I want to give it a parameter, an ID and a parameter. And you can see that doesn't work, so I click on that. Good. And now what I've got are 2 parameters. Now, these are the IDs and the names, right? So I'm going to use this. I'm going to create that. Now, this is Java, so I need getters and setters and toString and hash code and all that stuff, right? Oh, look at all that. So modern, so Java, okay? So Java. So instead of doing that nonsense, I tend to use Lombok. Lombok's a nice compile time annotation processor. Good stuff. And now I have an entity. So what I want to do is I want to prove certain things about it. And of course, you all know about this. You know about assert equals and assert true, get ID equals to 1, and you can say that the name is equal to Jane, right? Like get name. And you can run this test, right? So here's my simple test, run that. And you can even do more complex things. You can say re.getName, and you can use a matcher. See the second parameter here? Assert that takes a matcher. So here you can use hamcrest, which is already on the class path. You can say that I want to confirm that this name equals, ignoring case, Jane, okay? Matchers are great if you have some recipe that you want to reuse multiple times and you want to have a nice recipe to test that thing and you want to describe that recipe once. You can create your own matchers, okay? It's a very easy thing to do. But what I want to warn you is that you should not create a matcher by extending matcher. You see, they could have put this in the documentation, but I think they're trying to communicate with us. So do that instead, okay? Create a base matcher. The base matcher has a very simple contract, right? It's a very simple contract. Let me see. Okay. And what you do is you implement these two methods that matter, right? This and the matches, right? And that's the basic test. You describe the condition and then the error message, and that's it. You can create your own matchers and reuse them all throughout your code base. But okay, we've got this very simple thing. Now, let's test that we can save it to the database, right? Save it to the database is a good idea. So reservation entity or document. Actually, I'm using MongoDB. I'm using reactive MongoDB here. So reservation document test, public void persist, throws exception, okay? And what I want to do is I want to build an application that I want to test that I can write to the database, right? I've got this database running in the background here, and I want to test that when I create an object and then I annotate it correctly, that it gets mapped to the database. So stepverifier.createR. I want to test that I can then write that to the database. And I want to use the thing that I'm going to use in my production code to test that persistence. So I'm going to use a repository. A repository is a thing that allows me to handle the boring reading, writing, updating, and deleting of my data. So I'm going to create a reservation repository, okay? There's this. If I create that interface, if I create that class, it's just an interface, right? I'm going to extend the reactive CRUD repository. And here we are. Good. So there's my basic interface. That interface has methods that support reading and writing data, but it is just an interface. Spring will create an implementation of that interface for me at runtime, right, or at startup time. And so that implementation I need to get from somewhere. Well, I want to tell Spring to inject that reference. So I could do this, but of course, my JUnit test runner doesn't know about Spring. So I need to say that this is going to be run with a Spring runner, springrunner.class, and I need to say that this is going to be a thing that talks to the database. I could just do Spring Boot test, but what that would do is it would launch the entire application context. Instead of doing that, I want to do a MongoDB-only test. And so I'm going to use a test slice. A test slice brings in the auto configuration that allows me to work with only the objects related to MongoDB. You can see it creates a particular limited application context. It excludes all the other auto configuration and only brings in the persistence. This makes it faster and it lets me focus on the thing that I care about. So now I can use this, and when I do that, I get a reactive value back. Think of this kind of like a future. This value does not exist. So I need to subscribe in order to get the value. But of course, subscribing might happen on a different thread, and then you have to manage the threading and all that stuff. So it gets very tedious. So in the reactive world, we have this thing called step verifier. So I can say, I want to expect that the new reservation that gets persisted by the repository has the following shape, okay? So this will be result.getID. I want to say that this should not be null, right? I want to make sure that's not null. And result.getName equals, ignore case, Jane, okay? And once that's done, I want to confirm that the asynchronous value completes without any issues. So let's run that code. Let's see what happens, okay? Okay. That was the wrong one. That's the wrong test, friends. I should have ran the other one. Let me see. Reservation document test persist. Et voila. Okay. So that worked. We were able to save the data to the database. We were able to prove that it was able to get to the database and it came back and it didn't have a null. We should always test the negative. So here, I'm changing this to be wrong. It should fail, right? That's how you know your tests are working, if they fail when you expect them to fail, okay? That didn't work. Create, no, that's the old test. Reservation document, persist, okay? Good, it failed. Put it back to the way it was, and it'll work again. Okay, so now we have data in the database. Now the next thing I want to do is I want to build an HTTP API. So I'm going to go here, I'm going to build a reservation HTTP test. And I'm going to test that I can make an HTTP call to the HTTP service and get back the results that I'm expecting. Okay? In order to do this, I'm going to use the web test client. I need that web test client to come from Spring, of course. I'll create a webflux test, and I'm going to create a run with springrunner.class. Good stuff. So there's that. Okay? Now, what I want to do is I want to say this.webtestclient.get.uri http localhost 8080/reservations. I want to get the data that comes back, and I want to confirm certain things about it. I want to expect that the media type is application JSON. I want to expect that the status is OK. I want to expect that the body matches the following JSON path. Okay? And the path will be Jane, and I'm going to confirm that that attribute works. That's a JSON path expression. It's kind of like XPath, okay? Now let's see if this is going to work. Do you think it'll work? Of course, it's probably not going to work. I can already think of a few reasons why it will not work. But let's just see what particular one causes us trouble first, okay? All right, first problem. First problem, status expected 200, but was 404. That's true. We don't have an HTTP service. We don't have any HTTP code. So let's go to our production code here. And we'll say reservation HTTP configuration. All right. And all I want to do is define a reactive HTTP endpoint. So we say bean router function server response routes turn route dot build. Okay. Dot get /reservations new handler function. Good stuff. Now, this functional reactive endpoint is going to inject a repository, and it'll send the response back. So reservation.class, there we go. This, of course, can be used as a Lambda, rewritten as a Lambda, and there's my functional reactive endpoint. Come to my next talk, and we'll look at the details of reactive programming. But for now, here's this, okay? So we've got that endpoint. In order to use this, I need to import it into my HTTP test here. So I will say @import reservation HTTP configuration. Let's run this. Should this work, do we think? Still failed. What happened now, huh? Well, my friends, remember what I told you about test slices? Test slices ignore parts of the application context. They only load the objects related to a specific part of the application graph. And so here, we're trying to load this web application, and it's saying, hey, I don't have a reservation repository. It doesn't know where that is, right? It doesn't have that because it's a web slice. It's only loading the web tier components, no data tier components. It's isolated those. So how would you solve that? You've got a particular test. You're trying to test one specific thing in isolation. You don't want to test the whole thing. You want to test one little thing in isolation. Well, you've got other parts of the graph, other parts of the object graph that you want to substitute out. You want to mock that thing out, right? There's a couple ways to do this. One is to use your own configuration class and then contribute your own mock version of that, maybe using Mockito. Or you could skip a step and use @mockbean, and mockbean uses Mockito behind the scenes. But what it does is that when you annotate a Spring field, a bean like that, it creates that bean as a mock keto bean. It registers it in the application context, and it makes it injectable, right? So if the bean already exists, if there's a bean of this type in the application context, it replaces it. Or, as is the case here, since there is no existing bean of that type, it adds it, okay? So it's going to add that to the context. And actually, I said mock, but I don't really want a mock, do I? Because a mock is just an empty object. It returns null and false and 0 and all these kinds of default values. What I want is not something to just take the space that an object requires. What I want is something to return pre-programmed results. This is called a stub. So I'm going to create a stub. I'll say this.findAll, then return a flux.just new reservation, passing in that. Okay? So I'm telling Mockito that when somebody calls findAll, I'm going to return this sample data here. Okay? So there's my reservation HTTP test. Let's see if that works. All right, good stuff. That's working. It's green. So now we can go back to the start.spring.io, refresh this, and we can build a client. Okay? So this is going to be a consumer to our API. We're going to create something using the stub runner. Stub, hello, runner, 2.2, hello. Whoa. Consumer, stub runner, Lombok, reactive web. Okay, and that's our application. Oh, cancel. Cancel. I did something wrong, friends. I did something bad. Okay. Hit generate. Good. Go. Hello. Making me sad. Okay, consumer. Options. 13. Lombok. Stub runner. Reactive web. Generate. Sorry? Oh, pop-up. Why would it pop up? Always allow. Always. Gee. Okay. Good stuff. So there's the application. I don't want demo. And I don't need producer.zip anymore. So I'm going to open up the consumer.zip. And this application is going to be a client. It's going to talk to the service that we've just created. And we're just going to test that we can actually talk to the thing that we just created with ease. So here's my JNet 5 test. Let's roll back to JNet 4. Okay, so I'm going to use that. And exclude this thing here. Good stuff. Now, we make this a public class, make it a public test, no problem. And say @enable auto import. Okay, good. Now, what I want to do is I want to just call that service using a client. And this is going to be a client that I expect other teams will probably want to use, right, to talk to the service. They don't have to, but it's nice to have a pre-written one that you can use that already knows how to do all the authentication and that kind of thing, especially nice in a microservice environment. So here I'm going to create a production class called Reservation Client. I'm going to actually inject that here, right? I'll just inject it. I'll say @autowired Reservation Client. Okay. This will be a Spring Runner, so run with springrunner.class. And I'll use the client. I'll say this.client.get all reservations. Well, of course, that type doesn't exist here, does it? So I need to create that method here. I need to say create a method returning a flux, a reactive type of reservation. So, of course, this doesn't exist. So I'll create the DTO, a client-side representation here, and it'll have the following attributes, all right? There's my DTO, my dummy object, to convey the data across the wire. And here, I'm going to use the reactive web client, private final web client, okay? So there's this. And of course, I want to inject that into the constructor. So I could create a constructor, or I can just use Lombok. So now I'm going to say return this.client.get.uri localhost 8080/reservation. So this is a reactive, non-blocking HTTP client. As the data gets made, as the request gets made across the wire, I'm going to, retrieve, body to flux. I'm going to turn the JSON that comes back into a reactive stream of reservation entities, or documents, or DTOs, okay? So there's my simple call, and what I want to do is I want to confirm that the data that comes back across the wire matches the shape that I'm expecting. So I'll say r.getReservationName equals Jane, and I'll confirm that r.getID is not null, and I'll verify complete. And if we run this code, what do we think is going to happen? Let's see what happens, huh? Let's see. I think it'll be fine. It's probably going to be okay. Maybe. Possibly. Oh, who knew? Okay, well, actually, that was my fault. I knew that was going to, I didn't know that one was going to break. Wrong test annotation. Here we go. Now we try again. No, that's the actual class. Come on. Computer. Go, computer. All right. So there we go. I ran this. What happened there? It's complaining that I don't have the bean for the web client, right? It's saying that I couldn't inject the web client, and so it's not going to work. That's fair. So we go to our production code here, and we just define the bean, a reactive, non-blocking web client. And you notice that I'm very happy to discover this stuff as I'm coding, as I'm running my tests. So here's my contract consumer application test. Run this again. All right, still failed. Now what happened? Oh, there it is, huh? Did you see that? That's not good. We've gotten into a bit of a problem, haven't we? I'm trying to run this test, and I'm trying to call that other service, and it's not working because the service isn't running. So of course it's not working, right? Of course it failed. There's no way that's going to work. And now we get into a bit of a trouble. We get into some problems here. How many of you know about the testing pyramid? The testing pyramid says that you should have, at the very top of the pyramid, the most expensive, most painful, most slow tests. These are usually end-to-end tests, exhaustive integration tests, smoke tests, these kinds of things that take a long time to do. And most of your code should be fast feedback unit tests and component tests, things that don't take a long time, so that you can cover 80% of your code in almost, in like 20% of the time, right? You want to have that inverted. So I'm trying to test this code, and this is just a microservice environment, right? When you move to microservices, everything's easier, right? Sure. Well, not anymore, is it? Now we've got a problem. Now I want to confirm that my client works correctly with my service. But in order to do that, I need to start up the service. Oh, not good. This gets us into a moment to take a brief pause to talk about culture. Now, I'm not sure about the culture here in beautiful Ukraine, but where I come from, in Silicon Valley, in the States, in San Francisco, it is considered very polite, very kind, very welcoming, very warm for somebody to say, when you start a new job, for somebody to say, hey, welcome, come on in, please have a seat. Here's a chair for you. Here's some coffee. I hope you have a nice day. That's a very polite, very nice thing to say. Wouldn't you think that's nice? I think that's nice, okay? However, in Silicon Valley, in San Francisco, in the States where I come from, it is considered very rude, very vulgar, offensive, very offensive to say, when somebody comes to your office to start their new job, you say, welcome, come on in, have a seat, have some coffee, I hope you have a nice day, and also, you need to deploy this Kubernetes cluster just to test your service. It's very rude, very, very offensive. Nobody likes this at all, right? People leave. People have quit jobs for this. And so this is the pain that we're trying to avoid. Nobody wants to be told, hey, I need to deploy my Kubernetes service just to be able to test my microservice. It's a very bad thing to say. So what we want to do is we want to mock out that HTTP API, just like we can mock out a collaborating object in our unit tests. But the thing is, that service doesn't give us, there's no compiler verifying that what we do in the client matches what's happening in the service. So one option I could do is I could use wiremock. So here's wiremock, autoconfigure wiremock. I'm going to run this on port 8080. Okay. Now this is a third-party API. Works nicely for these kinds of things, especially where you have stable API. So you can say wiremock.mock stub for wiremock.get wiremock.url equal to /reservations. And will return wiremock dot a response with a header. And then the job here is just to mock out the body, right? The body and the status code. So HTTP status dot OK dot value. The headers will be HTTP headers dot content type, media type dot application JSON value. And the body will be a string, right? So var body. Okay. Now, this will be a JSON string, so I'm going to mock out that, like so. And I can't wait for triple quoted strings to come, multi-line strings, string literals. So here it'll be like this, and ID will be 1, and then name, reservation name, like that, will be Jane. Okay, and there's the body. And if I run this, well, first of all, before I run this, we clearly need to fix that. Good. Now, let's run this code again. It's green. Hooray! It's green. And the producer side of the code is green too. They're both green. Are we done? Can we go to production yet? Of course not, right? Because we have a subtle bug. And this is actually the problem. Wiremock is great when you have a stable API. But if you're working inside of an organization and you've got one team over there and you've got this team over here and they're both moving very quickly, they're both changing the API very quickly to reflect modern, updating demands and concerns and changes, then this problem, the problem is that the code is no longer stable, right? If you're using like the Facebook API, that's stable-ish, right? OAuth. Very stable. You can, if you mock it out with wiremock once, it works forever, or at least until the next OAuth version, right? Some APIs are more stable than others. But in your organization, things are going to change. So what we want is we want to be able to mock out the API like wiremock. We want to have an actual HTTP server. This actually creates a mock. It creates an HTTP server that lives for the life of this test. And when it spins up, it produces actual HTTP responses. So that's real fast, right? You don't have to deploy the whole service. But the problem is, it's not tied to the changes in the service itself. So we can miss issues. If somebody changes the API over there, my consumer won't see that change. And remember, if you refactor an object inside of a monolithic application, the compiler will tell you that you've broken something. But what can tell us that we've changed our API here? Wiremock won't work there. So what we're going to do is we're going to use contracts. Okay? Contracts are a way of describing an interaction with an HTTP service. They describe how you expect a request to go in and how you expect the response to come back out. So we're going to go back to our producer. We're in the producer side again. Okay? And we're going to go back to our code. And you can see that because we have on the class path Spring Cloud Contract Verifier, we have a directory here called contracts. And contracts, you can create 1 or 10 or 1,000 or 10,000, whatever. Each contract is going to be turned into a test. It gets converted into a test, and that test captures one interaction with your service, okay? And this is actually, in some ways, redundant with the web test that we did earlier. It does a lot of the same things. So you could have just started with the contracts, okay? So I'm going to say, I'm going to create a contract called should return all reservations.groovy. Now there's a Groovy DSL, there's a Kotlin DSL, there's a Java DSL, I think there's a YAML DSL. YAML. But whatever you want, right? So we're going to use contract.make, okay? And we're going to say descriptions should return all reservations, okay? And we're going to describe we're going to say that the request that comes in has the following shape, and a response will be produced out. So the request has a, it's going to come in at /get. It's going to be a HTTP GET request. The URL is going to be /reservations. Okay, that's one thing I'm expecting. I'm also expecting that the status that comes back should be OK.value. I'm expecting that the headers have the following content type, media type, application JSON value. And I'll create a body, okay? And here, I'm going to create a Groovy object literal. I could create a string. I could actually create the JSON in a string, but Groovy has this nice syntax. That's a list, just like in JavaScript. And I don't have curly brackets in Groovy in the same way, but I can use object literals by creating a bracket like that, ID1, and name will be Jane. So again, what I'm doing is I'm capturing what I expect this service to return. And notice that here, on the producer side, the attribute is called name. On the consumer side, I did it incorrectly. I made a mistake, right? One side doesn't match the other. So it was green on the consumer, green on the producer, but they would never have worked in production. So we go back to the contract, and the contract is testing what we expect to happen on the server side, on the producer side, okay? Now this contract will be converted into a unit test, into a test for us. So what I'm going to do is I need to tell, I need to know that when this gets converted into a test, I need to know that it's going to be converted into a test that has the same setup logic that we did earlier. Remember, we did @mockBean to mock out the object, and we did all the sort of basic stuff you need to get the machinery working. All that has to happen for our converted contract-based test. So what I'm going to do is I'm going to go to my build here. I'm going to comment this out. We don't need it for this. And this can be explicit, right? That's the right value for what we're trying to do. I also need to specify a base class. And there's a lot of different patterns here. But basically, for our purposes, our simple example, we're going to create a single base class for all of our tests. You can create multiple for each. You can have a pattern that says for each contract, choose the following base class based on a convention. Okay, Spring Runner, and it's going to be a Spring Boot test. I'm going to tell it to start on a random port. There's 2 different ways you can do it if you want. It doesn't matter which one. So random port, good. And of course, I'm going to import the HTTP endpoints, right? So reservation, HTTP configuration.class. And I'm going to say, OK, when the application starts up, I want to know what the current port is, so I'll inject that. I'm going to tell the test framework where the contracts should go to, what port they should talk to. Okay, that's this. And I also want to mock out my reservation repository. So mockBean reservation repository. And we can do the same thing as we did here, right? Okay, good stuff. All right, there's this. Good stuff. So there's our base class. And our build, our contract, is going to extend from that base class that we've produced there. Okay, base class. So now we can go back to our build here. CD producer, Maven clean install. Let's see what happens. Fingers crossed. Oh. Okay, so you can see it did the normal things. It installed the jar, of course, the artifact jar, into our local M2 Maven repository. It installed the pom.xml into the .pom file in the local M2 repository. But also, the plugin that we have configured automatically installed a stubs jar. This stubs jar configures a file. It creates a file that can be used by WireMock to create a fake HTTP service that matches the output of that contract. And you can see what I mean. Remember I said that it gets compiled into a test? Here's that, right? Contract verifier.java, okay? That's the file that got created for us automatically. That file looks like this. It says, when a HTTP request to /reservations comes in, expect the status code to be 200, expect the media types to be application JSON, and return with the following JSON, assuming 1 and Jane. And also, because we wanted to know about our Spring HTTP endpoints, extend this base class that we've provided it. So it's creating a unit test for every single contract. These contracts are great for capturing how you expect the API to be. So if you introduce a change, you can capture the break. This is great for making sure that if you evolve your API to version 2, you have contracts that capture how version 1 worked. Okay? So now we've got this contract. This is good. We've got a test, and actually, we could have just not written this test, right? This test is redundant in this case. We didn't need it, but I wanted to show you how. Now, we've got the contract where the contract really comes into its own, where it becomes most valuable is on the consumer side. So now, instead of doing all of that with WireMock, and with this, we'll get rid of that as well, I'm going to say auto-configure stub runner, And I'm going to say to the stub runner, I want it to go to Maven to find the artifact ID, com example, and the group ID, com example, and the artifact ID producer, find the latest version, and then run it on this port. It's going to find the WireMock stubs. It's going to create an HTTP service that runs on port 8080. It's going to find the latest version. This is very important. When you do WireMock, when you do continuous delivery, you build software, you write code, you make a change, you Maven clean install it, you compile it, you git commit and git push it. It goes to the continuous integration environment. The integration environment runs the code. Hopefully, it's all green, right? Your code's always green, right? Like Chuck Norris. The code then gets deployed into production, right? Every single time you make a change, it goes to production. That's continuous delivery. It's a very useful thing. What that means is that every single time you do a git push, the code in production changes. So you want to make sure that your client is always tested against what will be in production, which of course is always the latest version. So you could do 1.0. whatever, but don't. I recommend you use plus, okay? Now, the question then is, where is it going to find this contract definition? I installed it into my local Maven repository, like that, okay? So now, let's now run this code. Here we go. Whoops. We found the bug, didn't we? See that? We got a null pointer in there. So, null pointer exception. Why did we get a null pointer exception? Well, reservation name equals null. It created a HTTP service that looks like the producer side, but on the producer, we don't have reservation name. We just have name. And so this captured the bug. Something was broken on the producer side. The consumer side has been updated to reflect that. So we go here, change it to name, and we restart. Of course, the compiler will complain here. Get name. Good stuff. Okay, not bad. Now, we have used the contracts to capture breaking changes across microservices. My friends, this contract is in our local M2 repository. Normally, you would do Maven deploy, and it would go into your Artifactory or your Nexus or whatever, wherever your team members can see this, so they can share the contracts across the organization. Now, some of you, and this is only something I've just recently learned was possible. I didn't think this was a thing before. Apparently, some people, and again, I haven't seen it in the wild, okay? I haven't seen this for sure. How many of you know about the Higgs boson particle? The scientists at CERN discovered this 5-6 years ago. It's the particle that they credit with creating the universe. And it was scientifically provable, but it wasn't certain, right? They didn't know about it until they were able to conduct a laboratory experiment and find it. And so, scientifically, it's possible, but I haven't seen it yet. Science is not out there yet. Scientifically, it's possible to write code without using Java and Spring. Again, haven't seen it, but I know it's possible. So for those people that are not using Spring Cloud Contract, we have this nice jar you can distribute. So, okay, it's called Spring Cloud Contract. It's called the Spring Cloud Contract Stub Runner Boot Jar. You distribute this jar, and there's different versions here, and they just need to run a command like this: Java -jar server port equals blah blah blah. Here's the jar itself. You tell the stub runner jar to run offline, to use local, and to use the following artifact coordinates. You give them that jar. You give the person working on the iPhone experience, or the HTML5 browser experience, or the Android experience, whatever. You give them that jar and tell them to run this script, and now they can go to localhost 8080/reservations and get the same data as we have hard-coded in the contract. And the contract matches what's in production because it's actually testing our service. So now, these poor users, these poor non-Java, non-Spring users, don't have to deploy a Kubernetes cluster. They can go to work. Thank you, my friends. I appreciate it. I will be giving one more talk. Please come to that one. It's all about reactive programming. Who had fun? Okay, who learned something? Good stuff. Very good. Okay, I'll see you at the next talk. Thank you.